Hello, my name is Trent Pichikako. I'm the Early Career and Student Statistician Rep from the WA branch of the SSA. And just to introduce our session today, we're just going to do a short welcome to country. In the spirit of reconciliation, the Statistical Society of Australia acknowledges the traditional custodians throughout Australia and their connections to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. So this is our third session in the web, or the SSA's third session in a webinar series spotlighting the personal journeys of senior Australian statisticians who have made a lasting impact on the field. So this session features an interview with Anthony Pakes, conducted by John Henstridge, the Managing Director and Chief Consultant Statistician at Data Analysis Australia. The interview will run for approximately 40 minutes and be followed by a Q&A session. So just to introduce Tony shortly, and then I'll hand over to John. Tony is a Senior Honorary Research Fellow at UWA. He left school after Year 10, picked up diplomas in Communication Engineering and Applied Physics from RMIT, and worked 3 years at the Defence Standards Laboratory in the Chemical Physics section. He won a 3-year Department of Supply cadetship to complete his Bachelor's and Honours and Master's at Maths at University of Melbourne under the Commonwealth Aegis. He pursued a PhD studies at Monash, following a brief return to DSL. Tony then joined Monash University in late 1970 as a lecturer. Tony and his family relocated to Perth in 1980 to undertake a position at UWA. Tony's teaching covers many areas of probability, applied and theoretical statistics, optimization theory, service maths, history of maths in probability, currently branching processes, probability distributions, infinite divisibility, and modelling the Luria-Delbruck fluctuation experiment. Tony is a fellow of the Australian Mathematical Society and was an elected member of the International Statistical Institute. He has written over 75 journal articles in mathematics and statistics journals and has been cited over 1,200 times. Retired now, Tony was very willing to share his journey with the SSA. All right, so I'm going to hand you over to John now, and you guys can get started.
Right. Thank you, Trent. I think I'm in the fortunate position where I can remain off screen.
Yes.
And do we bring Tony onto screen now?
Yes, so he'll be on. Yeah.
All right. Okay. Right. Well, thank you, Tony, for agreeing to this interview.
Well, thanks for inviting me along. So,
all right. And before the interview started, we were discussing many parallels in our careers going back an embarrassing number of decades.
Yes.
Is probably the most polite way of putting it.
Yeah. The ancient of days is
Yes.
the biblical way of putting it. So,
Right. Now, as Trent mentioned, your getting into academia was not totally conventional by today's standards. And in fact, leaving school after Year 10, and then going into studying communications engineering.
yes.
What led you to do this, Tony?
The reason is that I had their interests which changed at reasonably well-defined points in my life. So when I was much younger, I was interested in astronomy. And in Year 7 at school, we started doing science as a subject in its own right for the first time. And our science teacher brought some apparatus and chemicals along to our classroom, and he did some experiments in front of us. And I was really very, very taken with that. And I wanted to do the same sort of thing at home. So I developed a very keen interest in chemistry and amassed a large amount of apparatus and reagents. And my father was an industrial and analytical chemist, so he had a number of textbooks in his bookshelves at home, and he gave me one or two of them. But that persisted for several years, and then I became interested in the model aeroplane flying. And I had a friend from the school that I was going to at the time to stay with me for a weekend, and he bought a copy of Radio and Hobbies, which is a magazine which doesn't exist anymore, and I'd never seen it before, but it had an article on about making a matchbox crystal set, and that really caught my imagination too. so the chemistry tended to go by the board, and I got very interested in radio. But when I was asked what are you going to do in the future, I always asked, I'd like to be a chemist. But somebody said, well, that seems odd given you're interested in radio. And I'd never really thought of trying to follow that direction. And so I just suddenly changed. And my father scouted around and found you could, there's this communication engineering course at RMIT. Well, it was the Royal Melbourne Technical College then. And the way that operated is that students would leave school at year 10 or 11 and started the diploma course. So from year 10, it was a 4-year course, and then you had to do a year's relevant work. So then you could graduate. So that would be the same time as if I'd gone to university in a 3-year bachelor's degree. But anyway, I did this diploma course, and I was invited to help to look around BSL as part of something which RMIT did, and I really liked the look of the place. And just before Christmas, my last year at RMIT, I was actually offered a job at BSL Defence Standards Laboratories, and so that's was my career up to then, and the work was specifically in microwave electronics, which I did for 3 years then.
Okay. What sorts of projects were you involved with?
Yeah, well, I was really couldn't recall very much, and one of the reasons is that I was a sort of a pair of hands for the senior research scientist whom I was working with, and then he sort of packed his bags and left after a year to go to take a job at CSIRO, and I was really left then pretty much unsupervised. But one of the things that I did was a big electron as a microwave gas spectroscopy set up, and a couple of chemists came out from Monash University. They were trying to get this device working, and so I was sort of helping them. But in the end, they gave up because it just didn't seem to function satisfactorily. There's one project I do remember that I was called out to one of the airlines was having trouble with water getting into the structure of radomes. So the radome is the front on the front of the aircraft behind which the radar system sits, and the radome material is 2 layers of fiberglass, which are sort of kept about half an inch apart by sort of a honeycomb structure inside it. But when the plane is in flight, it gets struck by the lightning, and lightning hits the radome and actually produces small holes on the outside, and they're flying through clouds. So then the moisture can get inside the radome and produce pockets of water, which degrade the radar signal. And the question is, how could they detect where these water collections were without having to pull them apart? I mean,
Right.
in itself apart. So anyway, it just seemed to me that you just apply the effect in reverse. So if you had a microwave transmitter and a small aerial behind it, and you could put the radome on a jig, so you could sort of swing it around, you could actually detect where the water is and drill behind, drill it out.
Okay.
And so they said, I just had to come up with an idea, and they do all the hardware, and they seem to be very, very satisfied with that. And I guess another thing that I did, which was not to do with microwaves, DSL was spearheading a very big project to simulate atomic blast in something called Operation Blowdown. And I was brought in as an extra pair of hands, by which I went to flew up with a large group of people to North Queensland, where a tower with 50 tons of TNT was set up on top of it, and that was just discharged one morning, very early one morning. And the reason for that is that atomic tests have always been done on islands or in very flat, open areas, in deserts or tundra areas in Canada was where some tests were carried out. And I think the worry was that all the foliage and the much more moist surroundings would dampen the shock waves and reduce the damage. And the question was really how to quantify this.
So was this one of your first data collection exercises?
Well, as I say, it was just an extra pair of hands. But yeah, there was a huge amount of data because they had pressure gauges and strain gauges on trees, and these pressure gauges were all over the place around the tower. And so we were up there. The final phase was 6 weeks. The whole project ran for 2 or 3 years, setting it up, and also small simulations up at Pakes, a proving ground near Ballarat. So I went up to a few of those just prior to going to the Iron Ring. So that was something which does stick in my memory. They made a film of it, which is showing the Tom doing it. So came out in the late-ish 1960s. So,
Okay, all right. From there, you went on to study mathematics, of all things.
Yeah, well, that was
at
just
University of Melbourne. How did that take place?
a bit of luck in some ways, or serendipity. When I was doing the communication engineering course, I had got very interested in mathematics and physics. There was no specialised mathematics course at Melbourne. There was a diploma in applied physics, so I did take extra subjects in third and fourth year physics, and I was encouraged then to finish the diploma when I was working at DSL. But a friend who I made out there, he had been doing the same course as me, but part-time, and he finished a year before I finished the physics course, and he discovered that you could get a Bachelor of Science in mathematics by a combination of evening study during the day at the University of Melbourne. So he was in a different section, the electronics section, but he got permission to take time off to be able to do that. And I thought, oh, that sounds a good idea. I'd like to try that. But I was denied time off during the day. But as a throwaway, my boss said, it was the pure two honours subject that things might be different. And so I went in to see if I could get into that. And I was given provisional enrolment in pure two honours, and I did well enough to be able to stay in it. Then at the end of the year, I came, I think, equal second class honours, and that was really how things really started. Because then a certain Dr. Farron, so
I can't remember.
he became the chief defence scientist, but he really pushed in my very strongly in my direction to apply for cadetship, and that was how was successful in getting a cadetship, and that allowed me then to go to the university full time,
Right.
For two years, so I could do third and fourth year. But I had to make up a first year subject, and I argued to be allowed to substitute the third year subject in statistics, and I did that while I was doing a master's degree. But that sort of set the course for everything.
Okay.
But okay. But I wasn't the only one that actually found their way to university that way, because I knew somebody from RMIT who'd done the applied physics course, and then he went on full-time to university, and you might have known him actually, Richard Loy. He then went to ANU to work under Robert Edwards on Banach algebras.
Oh, okay.
So,
Yes.
and then he stayed on for his whole career at the ANU.
Yes,
So,
I do remember that name. Yeah, that's
yeah.
right. Yeah, from my time at the ANU.
You might have drunk lemonade, which his father's company would have made. So there was a soft drink company, Loy's.
Okay,
Lemonade. So,
I'm afraid I'm a bit
so,
ignorant
yeah.
of Melbourne culture.
Yes.
Okay.
Um,
So that you got into doing statistics as part of originally trying to study mathematics.
well, I majored in pure and applied mathematics, but you had to do an extra subject in second year, and it seemed to me the logical one to do was the theory of statistics, part one. So in those days, you started in statistics at second year level.
Yeah.
And then, as I said, I quite enjoyed the distribution theory, the more theoretical side of it. And so rather than doing a first year laboratory subject, I argued to be allowed to do a third year subject at the honours level. So, and my my preference was the theory of statistics, part two. So, and eventually I managed, with the support of the Dean of Science, who was one that was a professor of mathematics. So, so that was permitted. So,
Okay, right.
and then also doing my masters at Melbourne, I sat in a number of statistics units, because that was about the time both the mathematics and statistics started sort of packaging up their subjects for separate units, and you could choose from a certain number of different subjects. So,
Right. Okay.
so I did down from the ANU. He gave a unit on Markov chains, so I set on that and a few other things. And well, Professor Pittman from Tasmania did a double unit in distribution theory for this third year statistics unit, and I found that very interesting. So,
Right.
so that certainly helped shape my interests.
Okay.
Sorry,
So-
guys, we'll get on and stop microphones because I think one of them's coming through.
Having a problem.
You're all good now.
Okay.
Yeah. The at the end of your honours, you then went on to a PhD at Monash rather than go back to.
Well, I did a master's, and that was in the Department of Mathematics at Melbourne, and I had my honours dissertation was in a sort of area of probability, actually propagation in randomly varying media. And the nearest I could get to something like that in the maths department was working with Bruce Craven, and he had some topics in probability in which he was working on at the time. So he steered me toward Markov chains and queuing theory. So I did my master's degree, and I actually made very good progress in about 10 months. So I actually finished the master's program quite quickly, and then I applied for a Department of Supply studentship to do a PhD, and my intention was to move to Monash, and because I had been out and talked to staff out there,
Right.
so, and that's what I did. So,
Okay. And the topic of your PhD work was what?
well, it turned out to be it changed a lot while I was doing it. So I originally, after talking to some of the people there, and having worked on queuing theory at Melbourne University, there was a long-term visitor at Monash from India, and he was saying that there is a lot of scope for applying control theory to queuing systems. So that sort of sounded on the surface interesting, so I thought I'd work on that. But when I got there, he really had little of substance to offer me. So I just started reading around myself and just generating my own problems. So there are a couple of things that sort of came out of my master's work. So I pursued them and published stuff, but just with reading, and I came up with problems which then moved me into branching processes. So half my PhD thesis was concerned with branching processes, and the first half was concerned with various topics in queuing theory and a little bit of Markov chain theory. But this gentleman went back to India after a year or so of being at Monash, and Peter Finch, who was the foundation professor of statistics, took over. But he actually said, "I'm not going to be able to help you." And we just had interesting conversations about this and that, including what to take away on my honeymoon. Take away some good mathematics book, as he said, because it takes ages for wives to get themselves ready in the morning. So that's so my PhD was very largely self-propelled.
Right. And then at the end of that, you had to go back to DSL.
I went back to DSL.
There were the days of cadetships having bonded time.
You were bonded, and I was bonded, I think, I would have been bonded for 5 years. But I had been offered a position at Monash. I'd loved it at Monash. And Monash, the mathematics department was just a terrific place to be at that stage. It was built up very quickly. I mean, Monash was a new university with a very big mathematics department and with a lot of freedom in what could be taught and the level at which you could pitch the material at as you went through first through to fourth year. And there are even master's subjects, which I did some teaching at that level as well. Anyway, I went back to DSL and I was put in an explosives and ammunition composite, and I didn't like it at all. It was not at all related to things I'd been working on. Although I realised, of course, you do a PhD, that's just a training in research, so that you can function as an independent researcher, and you can't expect to be pursuing your PhD work forever.
And explosives sort of taking you back to school time chemistry experiments.
Well, I used to make mixtures of red phosphorus and potassium chlorate, which was a really very effective explosive. In fact, that you didn't even have to contain it; it would just explode in the open. But anyway, after a few weeks, I decided that I disliked DSL so much that I asked if the position at Monash was still open, and fortunately for me it was. So I wrote a resignation letter, and I think after several weeks at DSL I was gone and back at Monash. And I made the right decision, in my view. So,
and it's and you were at Monash then for 10 years, roughly.
Yeah, 9 years. So the appointment started, I think, it was late November in 1970, and I taught 1971 through to 1979, and then I had been offered the position here at the UWE by Terry Speed. So I'd got to know Terry first at Melbourne, because he was a sort of rather wild-eyed, sort of monk-like or Rasputin-like character. But there was a student mathematics society which produced a magazine every year or two called Matrix, and he was editor for at least 1 year. And he was selling copies outside the room where the Pure 2 honours lectures were delivered. And so he said, poked it at me and said, "You can afford this." So I bought a copy, and we saw it. And I didn't, but he then moved on to do a PhD and lecture at Monash, and we got to know each other a lot better at Monash. And at Monash, Terry was one of the people that I very, very much admired, just because of his extraordinarily broad knowledge and his just sheer enthusiasm for mathematics. So
yeah, I can recall that time at UWA when Terry was professor, and understand the attraction of
Yeah.
coming to work with a place like that.
Well, when he got his PhD, which was in an algebraic topic, but he was in the statistics section at Monash. He's working with Peter Finch, who had also taken or had become very interested in the algebraic topics, particularly lattice theory, because that was regarded as a foundation of what he called quantum logic, and that was a big interest of his for many years. And he had a couple of students, and Terry was one of them, working in that kind of area. But Terry, I think, was more interested in just the algebraic side of things, and worked there, published a number of papers while he was at Monash. But almost as soon as he'd got his PhD, he took off for England to a job in Joe Garney's department. So we sort of lost contact. But then he wanted to come back to Australia, and he had a lot of difficulty finding a position, but he did land at the UWA as an associate professor, and then eventually professor and head of the statistics section in the department.
That period, 1970s leading into the early 80s, it seemed to me that Australia was just a powerhouse for studying stochastic processes.
And applied probability, that's true.
Probability.
So particularly the ANUs, you had, David Vere Jones was, he had probably left by the time I'd finished my PhD, but he was there with Chris Heidi and Chip Heathcote and Eugene Sinetta.
Yes.
So that was just a group of 4 people. It was a very, very strong group. And they just did lots of really good work, and quite a variety of sort of applied probability areas.
Right. I can remember my first statistics conference was in 1973, and I came across for it in Perth.
Okay.
And people were telling me, you must go to the talk given by this Tony Pakes guy. He's young and he's got a great future.
Okay.
People were saying that. People were saying that to me when I was
nice
in
of
the
you to
first year
say
of my
that.
PhD.
I recall that conference, and well, I actually was quite taken with just the campus here. I guess I didn't see very much of the city. They're housed in a hotel, and where I think there was the small bus which picked us up in the morning and then took us back at night. And it was, and it tended to be fairly late at night, so it was dark. And so I really can't place where the hotel was. I remember looking out of the window in my room. There was the sort of high-rise building, and the glass in the windows was a kind of greenish blue colour, and I think that ought to characterise the building, but I can't remember.
I don't know.
What it is, what building it could have been. So,
Right. Yeah. How did your research work develop as you were at UWA? Did it change because of different people involved?
Oh, that definitely would have. Yes, that was the case. When I first came to UWA, we left Melbourne. Was very early February, and we were offered either air travel in economy or first class rail travel, and I decided to come by train to impress on the children just how far away we were moving. So it would no they would not be able to say, they can't, when are we going back home. So it was a 3+ day journey. But when we got here, it was a day rather like yesterday, extremely hot, and we left Melbourne. It was the top temperatures there were in the low 20s. So that was a huge culture shock. And we were put up in Corrine Gardens, the flats there, and our flat looked east. So we just got the sun blasting through the window very early in the morning, and the apartment would heat up in next to no time. But Terry could sort of see that I wasn't all that happy. So he actually gave me some material that he had been working on with some people in the Department of Agricultural Economics on income distributions and Lorenz curves. So I sort of got very much into that then, and I still got a large amount of unpublished material in that, which, as far as I can see, is unlike anything which is in the literature.
Right.
But so that was one change of direction. I still pursued my applied probability interests, but I think the following year, Simon Tavare had been given a position at Monash. He was brought across for a week, and then we started working on something together and wrote a fairly long paper on that. And then another visitor was Bob Griffiths,
Yes.
who got very interested in population genetics. And then he and I worked together on a project which has that was quite a while ago, but it seems to be dormant for a while. But other people have become quite interested in it. It is it's to do with sort of phylogenetic trees and most recent common ancestors, that kind of
Right. Okay.
work. And in fact, when I came into work this morning on ResearchGate, there was a notice of a preprint on that, which actually does cite the work that Bob and I did together. So I've asked for a copy of that, so I guess I'll get that in a few days'
Right.
time.
Okay.
But yeah, so... But,
You also became involved in lots of university affairs at UWA. Was that sort of voluntarily, or?
Well, not voluntary in the sense that I said, can I do may I do administration? So I can't imagine academics actually sort of putting their foot forward in that kind of way. But I think, no, it was because I was asked, I think. And then in the mid-90s, I became head of department, and that automatically brings a lot of committee membership. But, your written question said, sort of, did I find that an imposition? And just looking back on it, my answer is no. I don't think I did. I just took it to be giving me an opportunity to see just sort of other aspects of the university which you would miss by not being doing that kind of work. That's just service work, which I think all academics are expected to participate in. So,
Right.
And so I didn't regard it as a huge imposition. I just made the necessary adjustments to fit it in. So
Okay.
And some people I quite enjoyed. I was on the PhD committee until I went on a sabbatical leave, and I found that very interesting sort of work. So it gave me the opportunity to see what other people doing, sort of up closer than would be the case than just by sort of seeing a list of papers which might come out of the department that they're in.
Right. You retired, in theory, in 2012, but I see that you're still very active in doing research.
Well, it was a semi-forced retirement, so I had actually been wondering, because I was, I guess, was approaching 70, and I thought, I really should be thinking about retiring, but it was sort of forced in with one of these restructures where staff were being let go because the faculty consisted of all the engineering departments and mathematics and statistics. The faculty was just overspending, apparently, to the tune of what was $100 million in debt, and a new dean had been appointed. And he told us that his primary job was to get the faculty back working in a financially responsible way. And the way he did this was just to decide people that could be let go first amongst general staff, and then the academic staff were called together, and basically you had the opportunity of retiring, and there was quite a good severance package, or reapplying for your job, and so I opted for retirement. So, but part of the retirement package was that if you wanted to, you could be given an appointment as honorary research fellow. So that's what I did, because I didn't want to stop mathematical activity altogether. A lot of colleagues who do retire just bang, they just stop that sort of, they stop their mathematical statistical work, and they do retirement stuff at home,
Right.
I guess, or whatever it is. So,
Okay, and but I see that you've still been very heavily involved with statistics, and you've been very active with the Statistical Society in Western Australia.
Like mathematical, I like being a mathematician, so why would I want to stop it? So there's the research side of it, but as part of the deal of keeping these honorary appointments going, I mean, the letter of appointment says that if you're asked to do things for the university, you're sort of expected to say yes, and I do get asked to do a unit a year at fourth year level, so I say yes. So
okay, right,
and it's not too onerous. The students they're quite interesting. They're pretty bright, and the material that I teach them is quite interesting to me. So so there's no really good reason to say no. So
right. I noticed that you've published a recent paper which was on epidemics. An SIR model allowing recovery. It struck me, was this prompted by COVID?
Only very, very indirectly. The way that came to be is actually goes back a number of years, because in the 2000s I wrote a paper on the Lambert function and its relation to the classical Kermick-McKendrick or SIR model of epidemics, and that seems to have made me an expert in that area. It shouldn't, but it did. So I have been asked to referee a number of papers on mathematical epidemiology, and some of them have led me to do work beyond what was in the paper, but I never published it. And in particular, one of a little project I did was looking at second order properties of things like the numbers of susceptibles, infectious individuals and recovered individuals. And but as a result of refereeing another paper, it must have been, I was trying to sort of reconstruct in my mind how it all happened, but I must have come across a paper which came up on ResearchGate, which was a tutorial paper in epidemics, and it mentions the sort of stimulus from COVID. So that's the way COVID came into it. And this was published in a journal which I would never have looked at. I think it was a journal of mathematics and physics, online journal. But it had a couple of new sort of twists to the basic Kermick-McKendrick model, but it didn't carry the analysis, the mathematical analysis, very far, and instead it did just some numerical work with a bit of discussion. And I thought, well, this is just right for mathematical investigation, and it has the property that you still just have three categories of individual, and there are two constants of motion. So you could extend the kind of methodology used for the classical model to this new one. And I could also extend the second order unpublished work, which I'd done a few years ago, and to the new model, and get a very, very complete understanding of its qualitative properties and also some quantitative properties as well. So that's what resulted in this
Okay.
paper, which was published about a year ago now. So
The way you describe it, Tony, it makes me think that it's typical of the way that you pick up a problem that somebody else has only half done, and then you like to do it properly.
there are a number of papers which are like that, and which have resulted in a joint publication with authors who've submitted a paper which has been sent to me to be refereed. And my view of their paper is that it's not general enough and it doesn't go far enough. So I feel if I can make a very, very substantial contribution to what they have done, then I'd suggest to the editor that we publish jointly. And I always say that the authors have the option of not, and that's it. Then I won't publish separately. So that seems to me to be would be unethical to do that. But usually they say yes. I think it's only once an author has said no. So I just let that drop. So
Okay.
but
Right.
it definitely results. I think they're satisfied because it results in what I think is probably a much better paper for them and an extra one for me. So
Right.
so it's a win-win situation in my view, and I think they agree that it is.
Right. You've had a career of over 50 years in statistics.
Yeah, so do I have any wisdom to impart
So
to others?
do you have, yes, what would you say to young upcoming people who are considering a career in statistics?
Well, I'd definitely say go for it. So I think there's no doubt statistics is really is a great discipline to get into. I think part, A, for its intrinsic interest, and B, because it's just a good career move. A number of years ago, I found a statement by this very mathematically minded economist. His name is Hal Varian, and he's written papers on on books, at least textbooks on mathematical microeconomics, which we've actually used at UWA in the business school for honours level units. But I can't remember where he wrote this, but he wrote a paragraph just giving an extremely strong endorsement to statistics as a career choice. And he's more or less saying, this is the discipline of the future. You really should get into it. So
Didn't he say something like statistics is the sexiest career of the future or
just
something
about,
like that?
yeah.
Words something like that, yes.
Yeah. So I'd certainly strongly recommend and endorse statistics as a career move for that. And in terms of for what little wisdom I can offer, read widely. I think you really must do that. I mean, that's what I've tried to do, and you just sort of pick up problems which are sort of there in the literature, but you would miss if you didn't read widely, and you can develop them. And
Right. Okay.
so I think that's about it. So in terms of any wisdom I can impart to people,
Okay.
so just seems common sense to me.
Right.
So
Well, I think we've now got time for some questions. Are you going to handle that? Okay, I'll hand over back to Trent for that.
Thanks, John. If you have any questions, please put them in the chat and I'm happy to read them out. But Tony, I've got one for you first.
okay.
So I guess you've had a really long career in statistics and maths. How have you seen sort of the discipline evolve? And was there any sort of notable time points that you can sort of kind of point to?
I guess the advent of sort of desktop computers and the kind of packages which were available now has made a huge difference. In a sense, I haven't really got all very Shall I look at you?
Yeah, you can look at me. Yeah.
Yes, um, really not got into all that. It has affected some of my teaching because I've taught time series units. In the Markov chain unit, we were using Maple, and that was just ideally suited for multiplying up matrices and computing matrix exponentials for continuous time processes. And without that sort of package, you could just teach the theory, but there's no way you could have students actually producing numerical
Sure.
answers. So I think that sort of thing is a big and extremely beneficial change. And I guess now the development of statistics of those sort of these massive data sets and very, very high dimensional data sets as well. The high dimension seems to me to be very interesting because high dimensional Euclidean geometry has, the entities have properties which you wouldn't expect, I think, from our life in 3 dimensions. So that spheres with very, very high dimensions have most of their volume concentrated across an equatorial plane, and there are all sorts of other sort of interesting things like that. I did find a book in Boffin's which was on the high dimensional statistics. I've not really read right through it, but I have thought it would be interesting to base a unit at UWA on that. So there are other probability theory has become much more entwined with statistical mechanics, and I think now also condensed matter physics. And random matrices is a topic which seems to have taken off in a big way in the last few years as well. And that's there's a lot of interest in that for a very high dimensional multivariate analysis as well as the physics applications too. So but they're not areas which I've really got into. I tend to stay in one dimension.
Sure. Sure. Cool. There's a comment online from Tim Brown. He says this is a comment and a question.
Hello, Tim. I haven't seen you front in years, so I hope you and your family are getting on well. So
great. He says, so Tony is the most ethical and effective mathematical scientist in Australia, in my opinion, and a great leader like Alan James. He has not always been recognised, but will be. Does he know that this view is widespread?
No, I don't. I don't know. Let me tell you a little anecdote. It was one of the high points at my time at Monash was actually a year away from Monash. It was, I did my first sabbatical leave was at Princeton University, and at the time Stafford Moritz was one of the statistics professors. And when I'd been thinking of where to go, he said, well, my advice to you is not to go just to follow some particular scholar, because often you get there and you find that they've got all sorts of other concerns and they don't give you much time. Just pick a place which is nice to be at. And in the end, I opted for Princeton, and that was just a fantastic place to be. There was a statistics department there. It was very small. It was very social. They're very good students, as I taught 2 graduate level courses there, and got a lot of research done. But and it was also very Australian, as Jeff Botson was the head of the department there. Well, I didn't. He wasn't there for the first term that I was there because he was on leave. But the department had a sort of a social or party. I think it was that stage. The Department of Statistics at Princeton was going through, I think, was a sort of triennial review, and the way that's done is that they bring distinguished statisticians from elsewhere in the country, and they'd sort of hang around for a couple of days, talking to staff, talking to students, talking to Jeff, and so on. And then it was ended with a bit of a party. And my wife was talking to Jeff, and Jeff said, if I've got one sort of, not objection, but concern about your husband, he's too fucking modest. And it's I'm not very good at selling myself, so
Fair enough.
So I guess that's why I've never managed to. I did apply at the UWA to promotion to level E, and in the end I got knocked back. So anyway, and didn't try again. So
fair enough.
I should have. So
that was a great story.
Actually, in the end, it doesn't make that much difference. I mean, Uni Super is a very, very good superannuation scheme to be in. So I'm
There you go.
not having to worry about money. So
Yeah, cool. Cool.
but anyway, thanks Tim for that.
Yeah, thanks, Tim, for that question.
assessment. So
Cool. Okay.
yeah, no, Tim was a great student. I mean, he was a student at Monash, and he was actually sat in on one of these master's level courses which I did there, which was on the Brownian motion and the potential theory, which was a very interesting unit to give. And one of my colleagues was Joe Kupka, who was an American measure theorist who was extremely sort of picky sort of person, and he would just sort of pick you up on all sorts of mathematical points. So it was actually a very stimulating unit to give, partly because of that. So
Yeah, cool. Nice. Okay. Well, I think that probably wraps us up. So on behalf of the History Standing Committee of the SSA and the Early Career and Student Statisticians Network, Tony, thanks a lot for joining us, recording.